This is a demonstration of several plugins I've developed to form a system of reactive backing. This system allows the backing and the musician to interact to manipulate the tempo, the dynamics, and the transport of the backing track. The hardware used is a laptop, audio interface, a USB MIDI foot controller, and a modified Wiimote. This is the nunchucker off the Wiimote, which is connected to the main Wiimote transmitter. The first device is Wii Relative Tap Tempo. This is a modification of the Relative Tap Tempo device that I made a demonstration video of in 2013. So please see that for more information. This device controls the tempo of the Ableton session in almost exactly the same way. But instead of using data from a foot controller, it uses the accelerometer data from a Wii Remote nunchuck. The device uses the excellent AJH Wii Remote external created by Alex Harker to interface with the Wii Remote. Now the inners of the nunchuck have been mounted into an exclosure which is attached to the laces of my shoe, as you can see here. The nunchuck is connected to an extension cable. This goes up my jeans and it allows me to put the Wii Remote transmitter into my pocket or put it behind me. So the device also gates out any movement other than foot tapping. You can see it reacting here, but when I press play and it sees a movement other than an obvious foot tap that's off the beat, it'll stop any information going in for 2 beats. These are the controls to the right of the tap sensitivity, which are threshold and window, which control the gate, and the gate light will come up in the middle if that is activated. So I'm going to start by demonstrating the Wii Relative Tap Tempo device by looping a small section of music, causing it to speed up and slow down in reaction to my foot tapping. So it's pretty quick, I'll slow it down now. So if I'm behind the beat, it'll hear a new tempo and update that proportionally. If I move my foot, then you can see it gates. The second device is dynamic control. This uses incoming track volume to control the dynamics of up to 5 other tracks by adjusting the drive parameter of either the velocity device for a MIDI track, for example the piano here, or the gain drive device for an audio track, for example the bass here. So the piano has a velocity device inserted at the beginning of its effects chain, and that drive, as you can see, is being controlled by the guitar track, the dynamic control. Same again with the bass, only because it's audio, I've put the gain drive at the end of the effects chain, and its drive parameter is being controlled again by dynamic control. There are 2 modes of operation. It can either compare it to a set value, which is the mode it's in at the moment, or it can write a table of values in case you've got louder or quieter sections that you want to compare it to. There's an averaging function, and it gates out any really quiet signals using this gate function. So I'll press play on the same section of music and make it go quieter and then louder. You'll notice that the display will go red when it's quieter and green when it's louder, giving you a visual indication of how much dynamic is being changed. So about standard volume, and then get a bit quieter. Just really tickle it now. Now, start to get a bit louder. The third device is for loop, a single button that enables multiple loops, up to 4. This was creating the loops in the previous 2 examples, but you can have, like I say, up to 4 regions. So if you're playing a track live and there's an area that you might want to stay on, for example, the bridge, you can create 2 cue points in the area that you might want to loop. And so long as you're within those cue points and you've got loop on, it will continue to loop within those. And if you want to come out, so long as you hit loop off before the last beat of the last bar in that loop, it will simply continue. All of these devices are available free to download through the maxforlive.com device library. And this is a demonstration of all the 3 devices working together.